So we'll be covering basically some of the, um, you know, uh, built-in data types that C# supports, something called as type conversion. We probably can skip complex data types. Don't need this at this stage. Um, Actually, sorry, no, this is different. I was thinking of complex numbers, but this is basically talking about strings and enum. So yeah, so we'll cover this. That's not the other complex thing that I had in mind. Few things around nested loops, ternary operators, things like that. So like these are just like topics that didn't fit well into some other place. So it's more like I just put them together as one class so that we can just cover all these small spread out topics, um, and just talk over them and kind of take any questions in case you have. So code is the same as yesterday. There aren't any changes as such. It's exactly where we left off. So we'll just pick it up from there. Um, Probably don't need a lot of, actually let's leave it in for now. But yeah, so let's first talk about inbuilt data types. So far, whenever we have needed to store some kind of data, we started creating something like an integer health. We created an integer float. Um, we looked at Boolean as one of the return type with true and false as possible values. But we never formally defined as such that what exactly is this, how does it work, um, what are the different types that are supported, things like that. So I thought it would be good to just take 10 minutes and cover at least the major important ones so that we're not missing out on anything important, right? Okay, so first you can know that actually you don't need to do this inside the player class, you can just do it directly inside main itself. Um, Let me remove this. Let me just comment this out. Okay. So far we know that we've looked at integer as a possible type. We have looked at Boolean as another possible thing that we have looked at from basically from like return values and such, right? There are other types like float. Um, then there is something called as double. Um, so these are like relatively, and then character is another one as well. These are relatively like more uh, commonly used data types, right? Um, so what they typically represent is essentially each of them is a way to specify how the content of internal memory is represented when it is read by the program. Okay, so what I mean by that is that I can have a number, uh, say 65, right? If I have an integer number 65 and I try to, even though it's an integer, if I try to read it as a character, it would come out to be as a character A, right? Because internally, an A character is represented as a number 65. 65, 64, I forgot. But it's, I think it's 65. I might be incorrect, just correct me in case I'm wrong. But in ASCII notation, 65 is internally the number that represents the character A, right? And then B represents 66, C represents 67, and so on till all the way to Z, right? So the point here is that when you look at that piece of memory which has 65 stored in it, it's still the number 65. When you read it as an integer, you read it as 65. But when you read it as a character, you read it as A. Okay. So the idea of these data types is that it defines that when you're reading something from the memory, how is it getting interpreted? Okay, what does it what does the other person understand when they read this number 65? If the other person understands it as a number, then they will get to understand it as 65, But if the other person understands it as a character, they'll understand it as A. Okay, so even though the data stored in memory is exactly the same, based on your reading of it, your interpretation of it changes. Okay, so when we talk about these data types, we're basically saying that at some location in the memory some data is stored, and right now this character E is referring to that location. Whatever is stored in that location is basically what E refers to. Okay, so by default, so each of them would have certain limit as well, right? So typically you would see, like, the limit will be defined something like X bytes. Okay, I'll come to what X is. So so normally you would see, like, if you literally, if you just Google for, say, like, C++ integer int byte size or something, it will give you a number 4 or 8 or something, right? So geek says 4, something says even 1. But the point is that this X bytes, whatever it is, it's that platform's way of defining how much space will be allocated in memory when you create a local variable int a, right? How much space will be kept aside for storing contents of a, and that defines the limit of how much a can hold. What is the upper limit of the values of a, and what are the lower limits of the value of a? Okay, so typically you will see, like, int has 4 bytes, but this can actually change. Okay, this is always dependent on the platform. So you can have a different platform. When I say a platform, means which operating system you're on and which compiler you're using, right? So based on the different compilers, if you look at some of the older compilers, their integer size could be even 2 bytes or could be even 1 byte, right? The newer ones support 4 bytes. So it will purely depend on what platform and hardware that you're currently talking about. So even though 4 bytes is a good approximation, but you can always be 100% sure without knowing which platform you're talking about right now. Okay, so from platform to platform also this particular thing can change. Okay, so when we talk about 4 bytes, what does that really mean, right? When we say about 4 bytes, it means that we know that 1 byte is 8 bits, right? So that means there are 32 bits of information that can be stored in this. So when we talk about 32 bits, then can somebody tell me what is the maximum value that we can store in 32 bits? So what is the highest number that I can store inside an integer variable, given that we know that it's 4 bytes or 32 bits? Anyone?
256.
Okay, so why do you say 256?
So 1 byte is 8 bits.
Okay,
No, sorry. Let me see.
so you're saying 1 byte is 8 bits. Yeah, that's correct. Okay, so 256 into 4. So 256 into 4 will be 1024. So can I not store a value like this? Can I not store this if it is 1024? Will this give me an error? What do you guys think? Okay. Actually, let's run and see. Does it give an error? No, it doesn't look like there's an error. So I can store 1025, but then how is that possible? We just said that, oh, we can store only 1024. Then 1025 is working. How's that possible? We can actually, just for the sake of it, also print it out, just so that we know that yes, the value got stored and we are not bluffing. Okay. Okay. So A is 1025. No. So we just printed it out. So it says A is 1025. There is no negative value there. So it works. So how do you get to 205, sorry, 256? How did you figure out that this equates to 256? How did you arrive from this to this? Anyone? Does everyone know that 8 bits would equate to 256? Okay, so Mangesh says 32 into 8. So where are these numbers coming from? 32 into 8, 256. What is the underlying math of all of these? Okay, so Karthik says powers of 2. Yeah, so that's correct. So essentially, so if you think about it, one uh, one bit, right, is nothing but a zero or a one, right? So we said 8 bits will be able to store 8 of these. So the limit becomes 2 to the power of 8. Okay, and this comes out to be 256. Okay, so now when we have 32 bits, right, that is simply 2 to the power of 32. Okay, so anytime you want to calculate the limit of something, whatever is the limit that you can store, right, the limit will be 2 to the power of 32. Basically you take how many bytes it is and convert it into bits by multiplying by 8, right, and then take 2 to the power of that. So 2 to the power of the bits is basically the maximum limit that you can store inside it. Okay, but there is a catch. So it's not exactly 2 to the power of 32. Can anyone tell me why? Anyone? So it's actually 2 to the power of 32 minus 1. Because remember, the first number that we can store is all zeros. Okay, so even when we have 8 bits, the highest, the different possible numbers that we can store is 256, but we cannot store the 256 as a number. The values that we can store are 0 to 255. So this is nothing but 2 to the power 8 minus 1. Okay, so 2 to the power of 8 and then minus 1 from it. Okay, hopefully makes sense. So this is not 8 minus 1, but it is 2 to the power of 8 and then minus 1. So this will come out to be 2 to the power of 8 will come out to be 256 and then minus 1 means 255. So we can store 0 to 255. Similarly here, we'll be able to store 2 to the power of 32 minus 1. All right. So now this is talking about just positive numbers, right? So we are saying we start from 0 and we go, if they are n bits, then I'm going all the way from 0 to 2 to the power of n minus 1. But these are all positive numbers. When I want to store negative numbers as well, right? So if I want to store between 0 and 7, which is basically 2 to the power 3, if I have 3 bits, right? I want to store numbers between 0 and 7. I can only store 8 numbers. Now I want to store both positive and negative numbers within the same 3 bits. Then what can I store? I naturally take this range and slide it left. Right now, if I want to store, so think about this, let me switch to output quickly. All right. So think about this not from mathematics, but from like within your head in terms of when you draw it out, right? So imagine if you have 0 and then you have 8, right? So you have this range of numbers that you can store when you're talking about 3 bits, right? Obviously 8 is not included, so you can only store up to 7 values, right? So you have this sort of a box, right? And you can store any number here, but we can store only positive values. Now what happens when I want to store negative values, right? All I do is this box will remain the same because this box represents 2 to the power 3 minus 1, right? So as long as my number of bits is fixed, I'm not increasing the number of bits. If I want to store negative and positive values, then all I need to do is take this full box and slide it towards the left. Okay, right now the box is centered here, right? This is like the center line for the box. Now I want it to store both negative numbers and positive numbers, correct? So all I want to do is slide this box so that my center line becomes here. So now what this will look like is your 0 will come in the center. That will be your new center line. Okay. You'll have some numbers on this side and you'll have some numbers on this side. But the length of this box will still remain the same because it's still 2 to the power 3 minus 1. So it can still store only 8 numbers. Uh, so you'll have basically uh, 3 numbers on this side and you'll have 3 numbers on that side. Okay. Does that make sense? So think about it, it's a box and then you slide it over. Now 0 becomes your midpoint and you can now store these numbers. Okay. So now you'll be able to store all the way from 4 to minus 4. Got it? Is that making sense, by the way? I mean, I could have simply told you the formula, but I just wanted to make sure that you guys understand what this actually means when we say we are storing only positive numbers and when we are storing only negative numbers, right? I could have told you. So you can see the logical representation here. This was 8, right? 8 is what? 2 to the power 3. This is 4. What is 4? 2 to the power 2, right? This is 1 lesser, correct? So whenever we are talking about both positive and negative numbers, you reduce this number by 1. So if we are saying that we have n bits, right? If we have n bits, then if we want to store only positive numbers, then we're going to store 2 raised to power n minus 1. But if you want to store both negative and positive numbers, so this will go from 0 to 2 to the power n minus 1, right? But this will go from minus of 2 to the power n minus 1 to plus 2 to the power n minus 1. Got it? So this will come out to be minus 4. This will come out to be plus 4. Okay. So, and that's how we got these numbers. So I could have told you this formula very easily as well, but understand what's the principle behind it, right? So you're taking this box and just sliding it over so that now your center is on the 0 and you have equal numbers on both sides, right? So you have equal numbers on the plus side, equal numbers on the minus side. And this is nothing but what you would hear when you hear about the term uh, unsigned, unsigned numbers, and when you hear the term signed numbers. Okay, so when you talk about the term called unsigned numbers, all you're saying is that these numbers are, they don't have a sign. By default, when something does not have a sign, it's positive, right? So we're talking about only positive numbers. But when they have a sign, that means they're either positive or negative. So whenever you see this interpretation or something saying, oh, we are talking about signed numbers, then we are talking about both positive and negative numbers. And when we are talking about unsigned numbers, we are talking about both, we're talking about just positive numbers. Okay. Sorry, I used a mouse, so this sort of like, freehand style writing. In case you guys don't like it or don't understand it much, just let me know. I'll try to use some other tool, but this just gives me the best flexibility to make something sort of clear. Oh, sorry, close the screen. One sec. Okay, so hopefully that makes sense. So that's how we sort of work with different types of uh, data types and different types of numbers. And the same thing goes with, when you talk about floats and when you talk about doubles, typically you'll see floats on some platform could be 4 bytes, on other platform it might be 8 as well. And this basically represent anything if you want to store something like 2.935, right? Like whenever there is a decimal point, you would need use something with a float, right? Double usually is, as the name suggests, is normally the standard is that it would always be the double the size of a float. So if you want to store even larger numbers, then this might be the thing that you need, right? So on a platform which says that float is 4 bytes, typically a double would be 8 bytes. Again, the representation is the same, floating point numbers, which have basically a decimal place and some numbers after it. And you have, if it is saying, if floats are like 8 bytes, then basically the corresponding size for double would be 16 bytes. Okay. And again, you can use the same 2 to the power n minus 1 kind of a formula to figure out how much, what numbers can you store in here. Okay. So the formula still remain the same. Actually, I know, I think, sorry, I might be wrong on that one. So some bits are used for the decimal precision part. So I actually will have to look up. I'm also not sure 100% how it's calculated, but please Google for this and let me know as well, because I'm also rusty a little bit on this thing. Frankly speaking, this is not something that you use on an everyday basis, so it's easy to kind of get out of touch with it. So, but please, it's important to note what the actual value is. So the formula for the same, I don't think will apply. Um, so my bad on that. But yeah, somebody please look it up and just let me know what exactly it is. Uh, yeah. Character, as its name suggests, like it's usually for storing a single character, and Boolean again for storing something like a true or a false, right? So typically, when you think about it, sorry, give me 1 second, guys. Yeah. Hey, sorry, guys. So when it comes to Booleans, typically you can only store two values, right? There's nothing else apart from true and false. So, which is exactly equivalent to internally storing a one or a zero, right? One indicating a true, zero indicating a false, right? But if you think about it, how much size or how much space do you guys think um, we would need when it comes to storing a true or a false. What do you guys think? So far, based on all the discussion, uh, what do you guys think is the size that we need? Anyone? Okay, so Karthik says 1 bit, Sai says 1 byte. Okay, others? So Karthik, why do you say 1 bit? Can you give us some insight into 0 or 1? Okay. So then others, when they say 1 byte, like, do you guys have some insight? Why do you say it's 1 byte? Okay. So in some sense, logically speaking, you both answers are correct. Okay, and the reason for that is when you think about it from an abstract level, right? Don't think about the implementation of it. uh, when you think about it from an abstract level, Karthik is correct because we just need to store 1 bit, whether it's 1 or 0, right? But when you talk about the implementation side of things, how computer systems implement it, right? The minimum size that a computer system can read at a time and store, they're typically programmed at the byte level, right? They read 1 byte of information together. So even though a lot of systems would implement internally booleans as 1 byte, even though all you're storing is a 0 or a 1, right? There are other fancier high performance systems that try to fit in a lot of, so if you have, like, 10 different boolean variables, right? Bool x, bool y, bool z, something like that, right? Like if you have a lot of these variables, you can think about is that you just need 1 byte of them all, right? 1 bit to store them all, right? You could put this information together into just 1 byte and save a lot of space rather than putting all of them into 1 byte at a time, right? You just take uh, out of the 8 bits, you assign b, the boolean variable b to bit 0, to boolean variable x to bit 1, boolean variable y to bit something else, right? So you can theoretically have a lot of well, actually not a lot, but exactly 8 booleans packed into 1 byte of information, right? So there are systems that do that. Typically, these are systems that are running in like very low uh, memory environments, like embedded systems. If you think about, like, Raspberry Pi, or your controllers that say control like automated lighting and stuff. Like if you like have like if you have like Diwali lights hanging out that display like a pattern, right? You normally get it with like a small box, and that box, if you open up, there is like a small chip inside it, right? These chips have a lot of small space, so for them, saving even the little bit of space when it comes to program is important, right? So usually those kind of systems where space is a big constraint, would you do some kind of fancy shit like this. But now when we talk about building regular applications, your systems and your phones and your processors and consoles, they have enough memory that they don't have to worry too much about the bytes. But under the hood, your compilers would still do a lot of optimizations. So more or less, those stuff are taken care of. So again, right? Ideally, yes, both the answers were correct, but when it comes to an implementation of the system, it will be at a byte level, not at a bit level. All right. Okay, cool. Hopefully that makes sense. Float, double. Any questions generally so far on like these different inbuilt data types. I don't think there is much more to talk about. If anything is not clear, I can go a little bit more deeper into it, but please let me know. Otherwise, we can move on to the next topic. No? Okay. Seems like good. So I'll start covering the next one. In case there is something, just please leave it in the chat. All right. So another thing that you can do is sort of type conversion. Anyone familiar with generally what type conversion is? What that actually means? I mean, like you can probably guess from uh, the English word itself, type conversion. Uh, Even if you're not familiar with probably the programming context of it, but generally speaking, what that means is that you're taking um, one type and converting it into another type, right? Type conversion. So normally, you can convert from pretty much any type to another type, uh, except for some caveats, right? So think about that. We said that integer can take 4 bytes, right? But then float can, or rather, let's say double for clarity, because double is always 8 bytes, right? So if you have a double number and it needs all the 8 bytes because it's a fairly big number, right? In that case, if you convert it into an int, right, the maximum you can store in an int is smaller than what you can store in a double. So depending on what the value inside the double is, there will be loss of information. Okay, and this is typically referred to as um, downcasting. Okay, so conversion slash casting is like the other terms, so typecasting or type conversion. Okay, so when we say something as downcasting, we are saying that we're taking a data type that usually occupies a bigger space and converting into a data type that takes lesser space. Okay, so typical example would be like a double going to a integer. Rather, a double is like the biggest one, so double going to pretty much anything is always a downcast, right? Even double going into a float is a downcast, right? A double going into a character is a downcast, into an integer is a downcast. Because downcast means that you're losing information. There is chance that you're losing information. Even if your double is something like, double is equal to 10.0, and you convert it into an integer, you're not losing anything because integer can also store a value 10. But it all depends on what the value inside it is, right? So there is a chance, depending on the value inside the variable, uh, that while downcasting, you will lose information. Okay. And typically the way you do it is, so if you have a double D like this, then, and you want to downcast it into an integer, so let's say an integer Z, then you would just put in a thing with a bracket, like the new, sorry, not double, but int. So you'll say that, hey, I want to take this D and convert it or cast it into an integer and then store that value into Z. Okay, so based on this, you're basically downcasting it and then storing it, right? If I remove this, what do you think? If I remove this, will it work? So if I remove int and I just say int z is equal to d, what do you guys think will happen? It's an interesting kind of a problem. So it will work, yes, no, no. Okay, so Taseem says no, Hardik says auto typecast. Okay, okay. All right, let's try it out. Okay, so first level, the compiler is not complaining. Maybe there is some issue that happens at runtime. Let's see. So let's try and run this. Well, let's do a printout actually, just to make sure that we are getting some value inside our variable z. Z as well. Right, so we'll just take this part and put it here as well. All right, so let's run. Okay, so as you can see, we have Z is equal to this. So this is something called as, like Karthik mentioned, like, auto casting. So what that normally means is that certain types are automatically detected by the compiler, where it knows that when it needs to convert a double into a int, it will drop certain information. So in this case, my D was 10.0, right? Like, let's add some, sorry, um, let's add some actual decimal part to it, right? So in this case, I know that this is a double number, which basically will store something, which will store a fractional value, like a decimal value, right? So at the end of it, when we are trying to convert it into an integer, the compilers are now smart and they detect that, oh, so we want to store a double value into an integer, so it will remove the decimal part, okay? And then it will give us the remaining result. So if you see the result now, Z is equal to 10, right? So it has dropped that decimal part because integers cannot store decimal values, right? They're just whole numbers. So this is what basically, yeah, this is like implicit casting, auto casting, there are different names for it. So So yeah, so similar to how we have downcasting, where there is a chance that you will lose information, like in this case, even though the number was fairly small, just because of the type being one that supports fractional value and the other that does not support fractional value, we lost this part of the information. Okay, so you need to be careful when you're copying values from one variable into another variable, so that to make sure that they are compatible. Okay. All right, cool. So what happens if I say int y is equal to int of e? Okay, so e is my character defined up here. So will this work? What do you guys think? So I'll just change this to say y, so that we can see what are we getting eventually in y. So what do you think will happen now in this case? This will work, okay? So what will be in y? Mhm. So Chaitanya says B65. Others? Anyone? Will we still get something? Will we not get anything? Will it throw an error? And let's run and check. So we get 97. Okay. So we got some number, but it's not 65. It's 97. And the reason for that is, I was saying that A maps to 65, but it's actually capital A that maps to 65, right? So first you finish all the capitals, so A to Z, that's 26 numbers, and after that you start with small a or something like that, right? So if I look at capital A, I think this will come out to 65 if I'm not mistaken. Yeah, so capital A maps to 65 and the small a starts after it, right? So it's like capital A to capital Z, and then small a, then I think 0 to 9, and then so something like that, right? But you get the point. So the thing is that, remember the very first thing when we are talking about the reading, the interpretation of it, right? So even though the number, it's a character, internal ASCII representation is still a integer number. So when we convert it, it's able to detect that. Okay. So in this case, we didn't lose any information. So similarly, like how we do downcasting, right? There is something called as upcasting, right? So you have the same concept, but in reverse when you say upcasting. In this case, there is no loss of information, right? Because as you can imagine, that what you're doing is that uh, you're taking a smaller data type and converting into a bigger data type. So giving it more space in the memory, right? So if something can fit inside an integer number, it can for sure fit inside a float. It can for sure fit inside a double. So if we were doing the reverse of this, right? Like you are taking an integer and storing it in a double, no information will get lost, right? Because it seems very obvious, right? Like an integer can only have 4 bytes, whereas a float can have 8 bytes, a double can have even bigger, right? So naturally, when we are going from a smaller type to a bigger type, will not lose information. Okay. So some key, like these are some key concepts to understand. And right now, we have looked at them only in the context of inbuilt data types. So character, boolean, float, double, integer, all these are inbuilt data types. But the same concepts apply to when we talk about custom defined data types. So classes are a best example of custom defined data type, right? Class is nothing but your own representation of something that needs to be stored in a memory. Okay, so character, boolean, float, even though these are specific terms that are given to us by the language, right? But they're nothing similar, but they're very similar to how a class is. So when we say that we've created a player class, right, it's as good as saying that there is an equivalent representation of it inside the memory that takes up some space and stores all the relevant information for the player, right? When you think about it logically, you create a object of player class and you create a local variable of the type integer. They're nothing but the same. They're just something that says that this specific memory has some data and this is how I'm going to interpret it. When you say integer, all you're saying is that wherever this a is, it is to be interpreted as an integer, right? When we were doing this, uh, yeah, so when we were doing this, all we were saying was wherever this player is stored in the memory, it has to be interpreted as a player. Okay, so now you can think about the same concepts of typecasting and type conversion to custom data types as well, such as my own classes. Now, of course, here things become more complex because A, it's your defined data type, right? So there are certain times when a compiler can do that auto conversion, right? That auto typecasting, right? It can understand if it can do that auto typecasting if the classes are in a inheritance hierarchy. Okay, so if you have a class, don't worry about, I'm just mentioning it here, but because we are covering the concept of typecasting, because typecasting doesn't stop at inbuilt data types, it can go to even your own defined data types like your classes and whatnot. Okay, so if you have hierarchy of classes like how we had, right? Like we created the player class, we created the high damage player class, we created the tank player class, right? So I can take a tank player class and like cast it into the player class, okay? And I can do a high damage player class and cast it into the player class. So kind of the same concept apply when we talk about inheritance as well. But if you're doing from a player class to say like an enemy class, then you need to define how that casting happens because the compiler cannot detect that itself. These are custom defined thing. So you need to define the behavior for the typecasting as well. Okay. We'll cover this in more details when we talk a lot more about like pointers and things like that. So just mentioning it here so that you guys are aware that casting can happen both at predefined inbuilt data types as well as on custom data types. But uh, you know, don't worry about it as of now, right? So once we cover dynamic memory allocation, the new pointer and those things, right? sorry, the new keyword and allocating memory and typecasting, those kind of things will come up again. Okay, cool. So far, so good. Any questions? All right, cool. So far we covered character as a single um, digit, right? Or well, not a digit, but a single character, right? So, uh, but that's not always the case, right? Like we want to store around the time string. Um, so C++ usually has its own sort of a string class defined as well, and you can normally do include for it as well. So string, yeah. So autocomplete works. So so you can just directly import um, the the string, and after that you can simply just define string as a variable. Um, well, of course, a variable, but I mean, like you can still define it like a very much like a inbuilt uh, data type itself. So, you know, the standard kind of thing work where you can do something like this and then do a C out on it. Okay. So internally, you know, you can think about string as nothing but a, a bunch of characters put together, right, back to back. So we'll talk more about it in future as well when we sort of cover the concept of arrays and character arrays. But one sort of a quick way of, you know, working with strings is you can directly start using the string data type itself that's by default supported as well. Okay, so something that you don't need to kind of always use character array. If you're already familiar with it, great in terms of character array. But if you're not, it's just an alternative thing of how to work with strings. Well, not how to work with strings, but I mean like the different data types that are available for you to use strings as one of the things to store any kind of data. All right, cool. Enums. This is like probably one of my favorite things uh, that pretty much every engineer that goes through me gets scolded on not using enums. So, can anyone tell me uh, what are enums? Anyone? All right, who is able to tell me can get some like special Diwali sweets or some shit? Anyone? Has anyone used enums? I mean, you can say no as well, just so that I know that you guys are still there. Yeah, but what are they? I guess that's what I'm asking. Never used. Okay. Okay. So they'll have default values and they'll increment each time. Okay. All right. Anyone else? Sure. Yeah. Enum is a keyword. All right. Used for increment. Okay. All right. Cool. So you guys are kind of close when you talk about what enums are, but pretty far off in terms of how we should think about using them. Okay, so I'll give you guys a quick example. So imagine if you have, you know, this player, and then you have this tank player, and then you have this high damage player, right? So comment this stuff out, and let's comment this. Let's get back our player code. All right. So typically, if I, like I was telling you, right? So player, um, say like test player, right? So we have some test player. Um, We have high damage player, we have tank player, we have uh, other kind of players, right? So imagine if there was like a function here that says hmm, void, um, what can we do? Something that detects what type of a player is, and based on that, it does something, right? So say uh, print uh, print player type. Okay, I didn't wanted to name it print player type because I think you guys might get confused a little bit with the actual type stuff. But for now, let's go with this and see if we can come up with a slightly better name there. Okay, so if you have this player function, which basically all it needs to do is that it needs to take input a player and tell us whether it's a player, whether it's a tank player, or whether it's a high damage player. Okay, so I can call this function through any of them, right? So I can call this print player type and pass in high damage player, right? Actually, I don't need this test player because I just created the other one. So here is an example of uh, that auto type conversion that we talked about when it comes to custom classes. So here my function takes an argument of the player class, which is the base class, right? Or the super class, whatever you want to call it, right? It takes player of the base class, but I'm passing an inherited class, right? You get the point. So here that auto conversion is happening by itself, right? I didn't need to do it. I can do the same thing for each of them, right? For the tank player, for the normal player, I can do the same thing, right? So I can do player and I can do tank player, right? And there are no errors, right? I don't need these damaged ones. So for now, just commenting them out. So all I need is that for each type of player, I need to define, sorry, for each type of player, I've called the same function and it takes the base as the argument. Okay, that makes sense? This is exactly what we were like talking about when we talked about that we can do type conversion for even custom types when the hierarchy is inheritance based, right? So these classes are getting inherited. The tank player class inherits the player class. The high damage player class inherits the player class. And that is why I'm able to do this. That is why I'm able to call a function that accepts the player class as input, but I'm passing a inherited class. All right? Is that clear? So now my goal is here display what is the correct type for the player, right? So if it's a tank player, I want to see out come out as tank player. If it's a um, regular player, I want to see the C out come out as regular player. If it's a high damage player, I want to print out high damage player, right? I want to do those things. Okay. So now what I'll do is there are multiple ways to do this, but the most sort of a beautiful way of defining it is that anytime you have these kind of things, you can define an enum. So we have an enum and we name it player type. Okay. And inside it, we give it a normal player, a tank player, a high damage player. I can do any names, right? The names are not important. These are just sort of symbolic representation. Okay. So what these are that instead of um, instead of creating, okay, so let me think how I want to explain this. So typically you would have seen code where it says that if x is equal to 0, then it is player. Else, if x is equal to 1, it is tank player. Else, if x is equal to 2, it is high damage player, right? And so on and so on, right? So if you've ever seen this kind of a code, that is the best place where you want to use enums. So enums are basically used to define a human readable way of storing sort of like type information. Okay, so this stores what type of a player it is, whether it's a, I'm going to call this a common player just so that, like, the player word doesn't get repeated. So whether it's a common player, whether it's a tank player, whether it's a high damage player, right? So anything of this type is a common player, anything of this type is a tank player, anything of this type is a high damage player. Okay. uh, Tank player, I think, yeah, the names are conflicting because now this has started to show red, right? Because the class and the enum uh, names are conflicting. So let's give it a slightly, uh, we'll call it common player type so that the names don't conflict. We're using it the same names, common player type, and this should fix the errors. Yeah, this should fix the errors. Okay. So the point is that I could have created an integer here saying player type and stored a value 0 here. Okay, and then in our tank player I could have created an integer player type and stored a value 1 here, and in my high damage player I could have created something like player type and stored a value 2 here. Okay, so in here what I'll do is, so these are going to be all private, so I can't read them. I'll need to define a public property on them, right? So I'll say get player type, and similar to how we had the get health point, right? We'll say return player type. We're just storing an integer, giving it a specific value, and then returning that value outside the class. Okay. And because I've defined it, again, using all the same concepts of inheritance, because I've defined it in my base class, I don't need to define it here and I don't need to define it anywhere else. Okay. So now when I say cout, player type is player dot get player type. Okay. Yeah. So now if I run this code, first we'll see this, it will say player type is have we 0 or 1? We have given 0, right? So it will print out first 0, then it will print out 1, then it will print out 2, right? Because first we are doing it for the normal player, then we are doing it for the tank player, and then we are doing it for the high damage player, right? And the high damage player says that its player type is 2, tank says its player type is 1, and player says its player type is 0. Okay. So far we have not used enums. All right. Oh, so here it says all are zeros. Why is that? Oh, that's because it's referring to this um, local player type. It's not referring to the player type that's inside, uh, that's defined in the child class, right? Because it's always getting called here, right? So it's always picking up this local value. It's not picking up um, the child value. So we'll have to override this function for now. Um, so let's do get player type and put it as a public function and do the same here. Run again. So now this will see, what? Why is it still saying? Oh, okay, got it. Hmm. Yeah, the reason is that it's not typecasted, right? Everything is typecasted to a player, so naturally only this player function is getting called. These functions are not even getting called at all. Okay, are you guys able to follow? I know this is like slightly complex, but the point here is that typically you never want your types, like your user defined types, to read like 1, 0, 2, 3, 4 as numbers, because over time it will become harder for you to understand what is the type. Okay, so let's simplify this a little bit and just move this out here instead of the function. We just move it out here. So we have player, we have tank player, and then we have your high damage player. Okay, so for now we'll just comment out the function and we'll fix the function once we first see this in action. Okay, so we have high damage player. What this is saying, get player type has an error. Where did we mess up? So we have the high damage. Oh, we didn't define it as public. So now if I run, you'll see 1, 2, 3 show up, right? So the first player type is 0, the second player type is 1, third player type is 2, right? But the problem is that as this project keeps growing, you'll have 0, 1, 2, 3 up to 10, 20, or who knows how many different types of players you might add, right? So suddenly someday you're reading code, if player type is equal to 5, do something, and then you'll go like, what the fuck is this player 5, right? And now you have to hunt through your entire code and figure out where is this player 5. Okay, so it gives a very unreadable way of defining information. So enums specifically are used to make information more human readable. Okay, so what I mean by that is that you're not defining as something as an integer. So when we use an enum, we'll instead change this entire player type to be, instead of an int, this will become player type, because this is exactly of this type enum. Now instead of generally saying int, we can actually say player type, and this is my player type. Okay, I'm going to comment this out because the variable name is the same, so it will cause conflicts. Um, so now what I've said is that I'm going to store my player type information as this enum. Because it's an enum, it can only store these three values, whatever I've defined in this enum. So this player type cannot be anything apart from these three. But when it was an integer, somebody could have come in and fucked up and written a million or a billion, and your program will still work. Just that everything, all the logic will break because this number doesn't correspond to a genuine player type. Okay, so enum basically solves two core problems. One, it makes your code more readable, because instead of using these arbitrary numbers like 0, 1, 1000, 10,000, 500, whatever, you are actually using human readable things. Okay, you're actually saying that my player type here is a player type dot common player type. So here you've defined that it's a common player type. Why is this an error? Does not refer to a value. Wait, what? Player type does not refer to a value. Int player score. Wait, why is this coming out to be score? Okay, 1 second. Okay, so you don't need the name. You can give it a full, just short name itself is fine. So What this is doing is that you can either say common player type, you can say tank player type, you can say high damage player type, but you cannot say anything random, right? But with integers, nobody was stopping you from putting a random number in there, and now that becomes a valid player type, but nowhere else that same thing is, matching up, right? In some piece of code, your common player type was marked as 0, in other places, suddenly somebody started marking them as 10,000, right? So integers generally are bad for that, right? This makes it very explicit that your player type can only be one of these three values. So it A makes it human readable and makes it less error prone, right? Nobody can go in and just do something like this random. Okay. And the other thing is that internally, so somebody mentioned auto increment things. Internally, all the enums are treated as integers only. Okay, so internally by default this would be stored as 0, this would be stored as 1, and this would be stored as a 2. The reason for that is that if you think about this thing, um, like the string common player type, if we were to store them as strings, these usually take a lot more memory. When you have to check whether player type is common player type, you have to compare strings, and that's usually very bad on performance. But checking an integer with an integer, that if player type is 0, internally it checks as player type as 0, but when you write code, it will be like if player type is equal to common player type, else if player type is equal to tank player type, else if high damage player type is equal to high damage player type, right? So your code is very clear that, oh, you're checking for a common player. If it's a common player, you're doing something. If it's a tank player, you're doing something else. If it's a high damage player, you're doing something else, right? So generally it just makes your code a lot more readable and clean, and still gives you the performance benefit of everything getting internally stored in the same way as 0, 1, 2, and 3. Just that you don't need to worry about storing them as 0, 1, 2, and 3, and nobody can suddenly come in and put in a value of 10,000. Okay, so nobody can fuck up like this. So it safeguards your code. You can give it custom values yourself, but generally that's 99.9% you never have to, right? You're using them to define certain type of information, and internally whatever it needs, let it store, whether it starts from 0, whether it starts from 1, everything is fine, because you'll always be comparing it with this. You'll always be saying player type is player type equal to common player type. You'll never say is player type is equal to 0. Okay, because that will defeat the whole purpose of it. And then when you're even debugging it, it's much easier, because then you'll be able to uh, you know uh, display information that this is of a common player type, this is of the tank player type, and things like that, right? So let's go ahead and fix this player type thing in all the other classes as well. So if we have this player type, um, yeah, we can have this player type as tank player type, and just comment this out. And the same thing goes for here. Instead, this is a high damage player type, right? And then we comment this out. So now whenever we do this get player type, let's see what it gives us. It still gives us a 0, 1, 2. So internally, it's actually giving us this representation, right? But what we can do is, the best part is, oh, the reason for that is that our get player type function, it returns an integer. It doesn't return this type. That's why we are seeing this 0, 1, 2. If I change this return type, you'll see the actual kind of a string show up, right? So instead, we want this to be player type. So now this get player type function returns a player type, but we have made this change only in the high damage player. So we want to see that for the other classes, our get player type is still an integer, but for my high damage player, it will not return an int. It will return like the actual type. Okay, so somewhere I fucked up where it is not returning the actual type. Let's see why. Okay, so this is get player type. It's returning player type. Okay, maybe it's a C out thing. Let's try. Sorry guys, I'm pretty rusty at this stuff as well. Usually C sharp is where I have the strongest hold on. But let's see. Hopefully, let's try it out. Okay, still nothing. Player type is 2. Maybe it's something to do with the C out. Anyone else has an idea? Player type dot no. So that's not the thing here, right? So the thing is that it's not displaying us the player type as a enum, right? We don't want it to display player type is 2. We want it to display that the player type is high damage player type, right? What we have defined here, right? We want it to display that instead of this. If it was an error, like you're saying, right, like use the full qualified name player type or common type or something, then that would have been a compilation error in itself, right? Like the code itself won't compile. So that would not probably fix. All right, so let me see, where else did we fuck up? Let's see, we're not using this function for now. So let's remove that. So we're saying high damage player, get player type is this. I think because of inheritance also, there are there is a get player type function which is in all the classes, right? So there is a get player type which has an integer, and then there is a get player type which has an integer, and then there is a get player type which has a player type as a return, right? So there are now two functions of the type get player type. So to be honest, I'm actually not sure which one it is calling, which is interesting. Does your get player type function need to be public? So we have it public, right? So I'm not sure which one you're referring to, Kartik. So the function is already public. In every class, it's public. So even in this class, it's public. Even in this class, otherwise we would not be able to call it, right? If it's not public, we won't be able to access it from outside the class, no matter what you do, right? So let's see. So I think, okay, let's try changing all of them. So it is get player type. Let's see. Okay, so still two. Hmm. Play type is something something high damage. Alright, so I'm not sure why we're not able to print out the actual enum as a string. So this might be something interesting for you guys to look into and even educate me on it. Uh, Clearly, my C++ is lacking when it comes to enums. But yeah, so something to look into. But the point is that it just makes your code a lot more readable. So tomorrow, when I have to do, uh, a switch case or an if statement, so I will simply do if my high damage player uh, dot get player type equal to you know high damage player type, and then whatever is my custom logic for it, right? Now this is much more readable than writing something equivalent to you know uh, this, where you type it to like a value 2, right? Like if you're a new programmer coming into the project and the project is already huge, which one do you think out of these two if conditions is the moment when you read it you understand, right? So, I mean, here the name is pretty clear, so you can probably guess. But if it was like something like just a generic player, you don't know what type of it is, right? That's why you have this get type function, and one says get player type is 2 versus the other place says get player type is equal to high player damage. You naturally know that, okay, this is something specific that you're doing when you're talking about an high damage player. Versus this, I have no fucking clue what this is. right? I need to hunt through my entire code to figure out where is this two, what does this two map to, whether it's high damage player, whether it's low damage player, whether it's fast player, slow player, whatever it is, right? I have no idea. So generally, enums are something that make your code a lot more readable. And anytime you're storing this kind of a type information, right? Your custom defined types have, things like this defined, then you would basically give them, uh, an enum. It restricts where all, like what all values the enum can take. So I cannot assign, some random player type, right? I cannot put in a value like that because this enum doesn't exist, right? So anytime I'm defining an enum, it ensures that I'm only using the enums that are defined here. One of the enums that's defined here. Okay, so I'm never accidentally putting in the wrong values, keeps my code a lot more readable, and generally avoids any kind of uh, you know unnecessary errors. Okay, cool. So let me try one thing. I think we might have to typecast it into a string for display. No, so string casting, wait, did we remove the string? No, we have the string. So I think it might be that by default it is casting it into a something else. Let, yeah, okay, never mind. We can move on. If we have time at the end, I'll quickly Google in front of you guys and we'll see if we can figure this out. But yeah, let's move on so that we can at least finish up all the things that we wanted to cover. All right, cool. So enums, will just come back to it at the end and figure out that scenario. Nested loops. So let's see. What do you want to cover in nested loop? Are you guys familiar with what nested loops are? Um, so we covered for loop, right? Uh, Generally, when we talk about, nested loop, can you somebody give me an example of where exactly, some generic example of where you would think we need to use a nested loop? So we talked about, a basic loop like something like, starts from a fixed number, goes from some value to some value, and then there is an increment, right? We talked about all this, right? And this way you can do, you can print it out. Like you can actually traverse over the entire thing. You can repeat something 10 times, something like that, right? But when we talk about something nested, it's basically a thing inside the thing. Okay, and what I mean by that is that you have one thing and then you have a small thing inside it, then you have maybe another thing inside it. So nesting, the whole idea of nesting is basically you have like a loop within a loop. Okay, uh, when we talk about nested loops, that's loop within a loop. But when we talk about anything nested, it just means something inside another thing. Okay, that's the generic way to think about nesting. So I could have another for loop inside it, and then I could, do something similar where I say I'm going from a local variable j, and then I iterate from j 0 up to j5, and I then increment the value of j, right? And I could come in and just print out the current value of I and the current value of j, and this will give you an idea of, yeah, okay, these are the different uh, sort of permutation combinations, kind of how the system is running, right? So if we do Padam and that, and let's comment other stuff out, so we don't need to run those. So all we are doing is, okay, too many things to on the screen, so let's just reduce the size of the numbers. So we have just 3, and maybe we have, let's start with something different. So 5 to 7. Okay, let's run this. So here you can probably see that, we are starting from different values of I, and for each value of I, we are entering into this loop. So it's like a nested loop. For one iteration of the bigger for loop, we are running a lot of operations of a lot of iterations of the smaller loop. And then once that finishes, we start the next iteration. So you can see for I is equal to 0, J starts with 5, goes to 6, then goes to 7, but 7 is less than 7, like 7 less than 7 evaluates to false. So this for loop ends, and then, uh, you start the next iteration of the bigger loop, right? So then your I goes up to 1. So you'll see again for 5 and 6 repeats, and then for, I equal to 2. And then when I goes to 3, the bigger for loop condition becomes false, and naturally the bigger for loops exits, right? So that's a typical sort of the simplest kind of way to think about nested loops. There is practically no limit. You can nest inside it, inside it, inside it, inside it. So this is like two levels, nested, like one loop inside another loop. You can have 3, you can have 4, you can have 5. So typically you can have as many loops as possible inside it. Theoretically, there's no limit to it, but generally it's bad for performance. The more deeper your nesting hierarchy is, performance is usually bad. So we do not, anytime you are going, beyond 2, I would normally say that, hey, there is probably something wrong here, right? Even 2 is usually not the best approach. More or less, you can sometimes think of alternative solutions to the same problem. Whenever you have even like, nested loops anywhere, but for performance, generally, it's considered to be a bad approach. So more or less you should avoid it, but you should still know about it, that in certain cases you still have to use it. So if you're working on like, so as Tasir mentioned, right, like matrix kind of a thing, if you have a 2D grid and you have to go left to right and, top to bottom as well, and you have to figure out some problem, solve some problem there, you probably need a nested loop to go both, like one row at a time and then all the columns as well, kind of thing, right? So you need some, in some cases you do need them, but more or less there are kind of, in all cases there are better ways of going about it as well. So not something very deep to talk about here, but something that you guys should be familiar with as well. Okay, cool. Switch statements. So kind of how we were talking about uh, the if and else condition when it comes to the player, this thing, right? Like, let me comment this out. So when we were talking about the player type, right? So when it comes to a switch case, uh, you know it's literally nothing wherever if you have a lot of if else if condition that are on a single variable, right? So if, you know so let's say we have player type, that's the, yeah. So player type, so if there is this player type and from somewhere we are getting its value, it's not important, some code here filled in the value of this player type, right? And now based on this player type we need to do some logic, right? So you'd normally say player type is equal to common player type, right? And then have your custom logic here, right? Else if you do player type is equal to your what is the high damage and tank, yeah. So tank player type, right? So typically in this scenario, your you know if else if, and then there might be another else if which is on the last one, right? Your high damage one. So this would be the high damage player type, right? So anytime you're running into this kind of a scenario where your if conditions are all based on one single variable, right? Like one single piece of information. Whenever that is the case, you can very easily replace this entire thing with a switch case. Okay, and what switch case does is that it lets you uh, put this particular thing, whatever is your your condition, uh, inside the switch parameter, and then based on that you can define your cases, right? So you're saying case something. uh, Typically a case would be basically whatever is on the right hand side of the equation, right? So whatever you can match this value to. So all this is saying is switch, uh, you know switch on this or not argument, but switch on this variable slash condition. If this condition evaluates into this, which is as good as saying if this is equal to this, right? uh, then you do something. Okay, and then you, sorry, writing pseudocode is so hard in this particular editor. And then you basically break. Break is basically just saying that okay, this case has ended, now we have to start the next case, which is my player type is tank player type, and then you write its own custom code, which essentially was inside this if statement itself. So all you're doing is you're replacing a bunch of if else with a switch case, which is generally considered a neater way of writing, uh, code, because you don't have to always do if else, and generally it's performance wise is also better, because the system knows that it needs to check for this player type to match to only one of these conditions, more or less, right? Like it will never match multiple conditions. Same way here, right? So most of the cases, this kind of a template can very easily be replaced by this. The only, so like if you have like that else case where it doesn't match to anything and you want to do something custom here, right? Then that usually comes out to be there is a fixed keyword called default, right? And when none of the cases match, in that case, the system program will start executing the default thing, which is as good as writing the final else case, where all these if conditions have failed and it executes the else, the same thing can be done inside the default case. Okay, so something like this, you can define your entire code. Cool. Any questions on the switch case? It's not something very deep or complex. It's just that anytime you see a pattern of you guys kind of saying, hey, if x is equal to something, else if x is equal to something else, else if x is equal to something other, just replace it by a switch case. Okay, it's just cleaner to read overall, better to write as well. Cool. Any questions? All right, cool. So let's write this out as well. What's next on the agenda? Okay, tertiary operators. Anyone familiar with tertiary operators? Like this kind of a thing? Have you guys used it? Heard about it? Okay, okay. All right, cool. So seems a few of you are familiar with it. Right. So it's like a shorter way of writing, you know, like a condition and then something, right? So if you're saying, int x is equal to 5, then, like if you want to do something like int y is equal to, now you're assigning the value of y based on the value of x. Okay, so typically you would write if say x is greater than 4, then you want the value 10. If x is less than 4, then you want the value say 5, right? So what this means is that expression, so what this expression before the question mark, whatever it evaluates into, if this is true, okay, then this is returned. When I say returned, means the result of this entire thing is this. So when x is greater than 4, then this entire thing could be written as just 10. But when x is less than 4, or less than equal to 4 in this case, then this entire thing could be replaced and written as just 5. So the way it would read is that if the x value is 5, in this case, int y is equal to 10. Because this condition evaluates to true. If it's true, then the first part immediately after the question mark gets executed. And if the condition is false, then this part will get executed. Okay. And you can make this as complex as you can think, right? So you can do something like if x is greater than something and z is less than 10, etc., right? So you can make this like a complex thing. So pretty much anything that you can put inside an you know uh, if parenthesis is exactly what you can put inside here as well. Okay. But there is a way you can even nest tertiary operators. Okay. So when I said that nesting is nothing but having one thing inside another thing, right? So can you guys think of how to nest tertiary operators? Anyone? Okay. So imagine that instead of something like x greater than 4 and z less than 10, uh, we want to do something different. We want to say int a is equal to, say, if x is greater than 4, then I want my value of 10. But when x is less than equal to 4, then I want to check based on the value of z. So I say z greater than, or rather we'll use the same condition, z less than 10, then do 3, otherwise do 6. So when x is greater than equal to 4, then use this, otherwise use this, right? And now this again is a tertiary operator, right? So it will again be evaluated like that. So z less than 10, okay? Then if z is less than 10 true, then 3 will be aligned, 3 will be used. If z is greater than equal to 10, then 6 will be used. Okay. And I could have replaced this also with something else. So if I had another variable here, int a is equal to something, the number doesn't matter, I could have replaced the true part of it with another tertiary operator as well. So I could have said if a is greater than say 3, then use 2 into a. Otherwise, sorry, this will be a question mark. Otherwise, use say 5, right? So now you can see that you can do a lot of like, this kind of a nesting. Right? So we defined a and a again. So let's just change this to something. Okay. So if x is greater than 4, then evaluate this. Otherwise, evaluate this. Now this itself is a tertiary operator. So it will get evaluated exactly like that. So based on this evaluation, whether this or this, I could replace this 5 with another tertiary operator, right? So you can keep making this as complex as possible, right? A good way to think about it is that you can give it a line break. Okay, so you can do something like this so that it gives you you know, sort of information on how to read it. So now this is much more readable. Nothing has changed. The compiler will still execute the code exactly the same way, but for you, it's much more readable now. Now you know, okay, first I'll evaluate this, then I'll evaluate this. If this is true, if this x is greater than 4 is false, then I'll evaluate this. And if there are a bunch of smaller tertiary operators inside it, you break them further down, right? Give them enter, 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 and break them on separate lines so that for you it's clear as to how to read this. Sometimes interviews will have these kind of stupid questions as well, just to check your basic understanding of can you interpret these things, right? So the moment you start seeing something complex like this, don't get confused. Just take your time, break it down into smaller components, and then follow one component at a time and done, right? Otherwise, if you put everything in one line, it seems fucking complex, right? And I can bring this to A into another kind of a tertiary operator, right? And then I can have this into another tertiary operator. So you can imagine that I can keep, if I really want to fuck with your brain, I'll keep adding more complexity to it. It's just literally very simple. So true or false? True, then this, false, then this. I don't even have to look at this, how it could have 5 levels of nesting. If I know that this is false, then ignore all this. Just directly jump into this. Okay? Cool. So nesting is not just in context of loops. Nesting can be done for tertiary operators. Nesting can be done for if statements. Nesting can be done for switch cases. So you can do nesting for pretty much a lot of things. Okay. Anything inside another thing, you can typically the concept itself is called nesting. Okay. Cool. Other types of loops. So there are do loop, well, do while and while loop. Uh, Anyone not familiar with uh, the do um, do while and while loops? Anyone? In case there is anyone who is not familiar with them, I'm happy to cover them. But if you guys are, then we can move forward directly and just skip over it for now, and just uh, look at both the project and then you know I want to fix this enum problem as well. So anyone who's not comfortable with the while loop or the do while loop. Okay. All right, cool. So I'm guessing everyone is familiar with it. You might have to use it on the project. So in case you're not, feel free to just quickly Google it, and then still something's not clear, then just put a message in Discord as well. Cool. So let's just quickly debug what the F happened with this enum, right? Like I won't be able to uh, print it out. Otherwise, I won't be able to sleep at night today. C++ enum cout. Let's see. Print as text. Let's see what we get. Yeah, we were doing that, right? So we were already doing that. Cout error A. What's error A? Error A. We are data using arrays, map arrays, string, character arrays. Okay, seems fuck all annoying that you need to do all this extra effort just to print this shit out using a map and whatnot. Yeah, so Karthik, what you just recommended, right? Like we did exactly that, right? So when you look at this, the earlier time when we were trying it out, right? Like this particular thing. So generally you need to do a typecast when that thing is returning you a different type of information, right? Right now our get player type is returning us the player type enum directly, right? So I don't really need to typecast it. But we even tried typecasting it just to check, but it still was returning us 012, right? And I think it's a C++ internal thing because if you look at the solution here, right, people are basically creating a hash map. Don't get too confused if you guys are not familiar with those kind of things. Um, but generally, just quickly looking at the solutions, right? Everybody has to implement a hash map and store a string equivalent of these enums, and then only you are able to print them out, right? It seems kind of like, well, if you ask me, it's pretty bullshit. So, let's look at if this thing has something. But if, yeah, Stack Overflow doesn't have anything, then I'm pretty sure um, we will not be able to print it out without using like a hash map or something like that. So it's doing a cast in color is blue. There is no, cast. Yeah. So okay. Seems like there isn't a clear way of doing something like this. Um, but yeah, I mean, like, you can have, just stumbled on this example, right? Like you can have an enum defined as red and blue for the type color, fruit, banana, apple, and then you can just have local variables of the enum, and that defines whether it's this or this, right? So instead of directly saying color is equal to, uh, like, why is he comparing color and fruit? Okay, seems like a bullshit example. Anyways, so yeah, it doesn't look like there is a direct, straightforward way of printing it out, but at least, we know that we can directly do the comparisons like this, right? We don't have to worry about, yeah. So we don't have to worry about, comparing the values to 0, a 1, or 2 and make our code look unreadable, right? So generally, that's how you should use enums. And anytime you define any kind of custom type information, please always use enums. Okay. All right. Cool. So let's quickly jump on to the sort of a weekend assignment for this particular week. So far we looked at pretty much all the basic concepts of object-oriented programming. Well, uh, some of the key core examples of object-oriented programming, uh, along with some fundamentals in terms of C++. So using the concepts that we have learned so far, what we're going to do is we're going to build a simple game. Okay, it's not going to be a game that has UI and not something that you're going to play on an Xbox, but we'll build it in Repel. And the idea is that you have to create sort of, how we've created three different players. So you'll create three different players. Each of them will have their own types of um, both damage and healing ability. So you will create these things as parameters, as different data types, as different, you know, uh, functions, right? So very similar to how we created a structure. So structure for like three different types of players. You already have seen them over and over again in the class, so you can use some of the base elements from there. But so far we looked at only the damage part. Now you'll implement the healing part as well, and both will change the health value of the player. Okay. So the goal is that when the program starts, it asks you to put in a number, 1, 2, or 3. Okay, and based on that 1, 2, or 3, you create a, a player of the type 1, type 2, type 3. Okay, so based on that, you will create an object of that particular player. Now, after that, you will go into an infinite loop where the user will press D for that. Whenever after a player has been created, you'll ask that, hey, press D for taking damage, H to heal. Okay, so when I press D, my player should take some X amount of fixed damage. Okay, and if I keep pressing D over and over again, eventually the health will go down to 0, and you can have internally all the three players start at three different health. So one starts at 100, one starts at say 200, one starts at say 1000. It's up to you. Okay. So the point is that each three players, or sorry, each three play like the players inside the game should be unique. They have unique health that they start with. They should have unique damage values. And when I press D, you should display out player took say 40 damage. Now health is 200. Then I press D again, player took 40 damage. Now health is 160, right? And then I press H, so player healed by 20 points. Now health is 180 points, right? So I can continue playing with D and H. When I keep healing, my maximum health is the maximum health of the player will be defined by what is the highest level health. Basically, when the player starts, when you spawn the player or when you create an object of the player, right? Uh, the health that you start with is its maximum health. So if the player starts with health 100, right, and I keep pressing H to make him heal, you should be able to go beyond 100. 100 is the max. So you need to make sure that whatever the number you're picking, it should always uh, go to that max value. Okay. Beyond that, it should not heal more. Same way how beyond zero, when you keep taking damage and you hit zero, you should die, right? You should not keep taking more damage after that. Okay. So now you will have this infinite loop till the time player keeps till the time the user, like if I'm playing your game, I keep pressing D, and when your health goes down to zero, then you should end the game and say player dead, game over, and then give the user another chance to say press S to start the game again and press E to end the game. If I press E, the program ends, game over, everything done. If I press S again, then it goes back to the top and says, press 1, 2, or 3 to select which player to spawn. Okay, and I can continue playing this infinitely for as long as I want, right? So I should be able to spawn as many players I want. I should be able to kill them without finishing the game altogether. Okay. Cool. So the instructions are all given here. I'm not precisely saying that, hey, you should have 100 health for the first, you should have 5 healing for the first, etc. It's a game. It's an ungraded assignment. It's for you to practice the core concepts that we have learned during this week. So I want you two guys to be creative and come up with your ways of how to implement them, and how you would like to express your creativity at it as well, right? So far, I'm pretty sure everybody has learned some of the core C++ fundamentals, some core OOPS fundamentals, even if not in C++ in Java, but all colleges give us like fucking bullshit assignments. So this would be a fun way to express your creativity as well, and try your hand at actually using OOPS concepts in a very fun, unique way. Okay, so you should be able to very easily implement this in one main.cpp file. You probably don't need anything more than that. So please try to give this a shot. If by Monday you're able to finish it, then please share your repel code directly in Discord, and others can check it out and give you feedback and such on it. Quick note: if you just don't want to share the source code, what you can do is you can share this link. So once your project is done, you can just share this link directly, and whoever clicks on this link directly comes into this editor, and they can start playing your game, right? They don't need to look at your source code, right? So they'll directly see like a terminal kind of a thing, and if your instructions are all set up correctly, they should see the right messages and they should be able to play your game. Okay, well, there's nothing here, but the point was, if there was a see out hello world, um, so this would basically translate into, so if I run this, right, typically we run this and you see the output here, right? If I share this link with you guys right now, you'll be able to run my code without looking at my code. Okay, that's a quick sort of a cool thing with the Repel environment itself. And why is it not showing me the output? One second. Mhm. One sec, let's try. Maybe it might be something with the website right now. Yeah, okay, probably something with the website, but normally you can just, uh, run the entire thing directly uh, into a separate thing. Okay, right now it might give us some errors or something. Let's see. Yeah, so here you can see, like, you get exactly, it's like clicking the run button, but without having access to the code. So you can see the output. If there was a scene statement that was requesting me to press a key, I can do that and continue playing your game. Okay, so you can share this with your friends, etc. Once your game is finished, take their input and feedback if they're able to figure out your game and things like that, right? So it's a cool way to kind of like build something quickly and then share it with your friends as well, and get some feedback on it. Cool. So any general um, questions on the project itself? Hopefully the problem statement for the project is clear. Uh, I've tried to give as many details as possible here. In case it's not clear, please do ask in Discord. Uh, I'm usually working 7 days a week, so even tomorrow you'll see me working on Discord.